Hey, welcome to the third episode of the Cloud Security Lounge. Today I'm proud to welcome Sacha. Sacha, you are Director of Security Engineering, which is both like product security and security intelligence at Grammarly, which has a French guy I'm a big fan of. Previously, you led payment security at Amazon, you were head of security at Lyft, and you managed the red team at Microsoft. Mm-hmm. So welcome, Sacha.
Thank you. Thanks for inviting me.
My pleasure. Could you let me know what is security intelligence and what does it mean for Grammarly?
Interesting, yes. See security intelligence as a mechanism to constantly push the bar and enhance the prioritization. So what is the learning flywheel mechanism that you have within the organization? And how do you actually enhance the prioritization with the standard intelligence feed, but also intelligence about your own mechanism as well? So early composition, security intelligence tend to start as a team and mature into a program that sort of affect the overall security decision. So looking at very early on, what are the mechanisms by which we actually validate or invalidate our assumptions? So very geared towards red team offensive security. What is our strategy around detections, right? What's the composition of our environment? Where do we have gaps? Where should we make the right bets? And what are, I think, a maturity phase, and you can start looking at PR frameworks, is what are generally the questions, intelligence questions that we want to answer? What are the sub-questions, indicators, and then requirements to answer that? And then you get the flywheel going very, very rapidly. So suddenly you start having better visibility or understanding some of the trade-off you're making. And the most important thing is work on what matters. What are the things that you're really worried about that you should act on, and operational excellence, how do you actually respond to that internally? So it's a never-ending space, but at Grammarly, it's very imperative for us that we are very transparent, but also continues to push the bar there to protect our customer data.
So I see that as a way to both work on the strategy of the security programs you're defining, but
Correct.
Also a way to ensure you have a great prioritization of the tasks you're choosing. Okay, very interesting. Thanks. So I guess that's also related to the today's topic, which is inventories. So if you want to establish a security program or something, you need to know what you need to protect, right? And so inventories are ways to do that. So Sacha, you have a lot of experience around inventories, and you built at least one, I know. Could you tell us what, just in a nutshell, what is an inventory to you, and why it's important in a security program?
Inventory is all the assets that you have. So what is the world that you actually have to protect, and what is its composition, right? So I'm always obsessed about getting clarity, transparency, and relationship between the components that we have to manage. So I'll give you an example, is like supply chain, right? You can look at the inventory as what you currently have, but what are you consuming as well? And what is the relationship with them? So for me, inventory is the sort of entire visibility of all the assets that compose your infrastructure that you have to protect, and also their relationship with each other. So it's both asset inventory, but also the ability to contextualize. I think that's, for me, overall what inventory is.
Okay, interesting. And so how do you leverage an inventory as someone owning a large part of security of a company?
Yeah. The key thing is, for me, that I was looking at is how do you actually make decisions? So I'm an engineer. spent a little bit of time on looking at decision loops, and the ones that became fairly easy for me to comprehend and kept it simple is the observe, orient, decide, and act sort of ODA loop, come from military. So for me, inventory really fits within the ability to observe the landscape, right? Like, let's actually enable ourselves to map the landscape. What does it look like? Orientation is the ability to actually ask questions and get answers and correlate things, right? So for example, you can have a large data set, which is your observe. Orientation might be the query language from an implementation perspective. Decision is really kind of the ability to implement your own decision-making, your own prioritization based on your context, right? So you can actually have more of a manual process in decision-making up to even some automated ones. And then the action is, let's actually do something about it and look back at the outcome of that, and goes back and observe. So you have like that perpetual decision loop that helps you guide. And it gravitates, it enables sort of the mission statement for me in terms of security is to empower the decision maker to make informed and automated decision, right? And how do we get the flywheel going very, very quickly and accurately and repeatable and daily, hourly, or even real time? So that's, to me, is like an effective asset inventory.
Okay, interesting. So I'm deducing from that you consider that such an inventory has to be real time, right?
There's a saying: everybody wants real time, nobody wants to pay for it, right? So it's the trade-off that you want to make. I think ideally, yes, real time, but do you even have the capacity to handle that, right? So find the right sort of trade-off balance. I think quicker is better, but you also have to consider kind of cost metrics there, right? So if you want to ingest everything all the time, perhaps that aligns with your need. And if you have unlimited budget, go for it. I've worked in an environment where I would say the constraint on budget was not really something we're thinking about. We're just aiming at doing the best that we could, and realized that the level of engineering required to do real time wasn't necessary.
Okay, interesting. And so, what triggered the need for you to build an inventory? What was the trigger?
So, I mean, without debating, I think knowing what you actually own, what it is your entitlement, is key. So beyond that argument, I spent several years as an IC. My last few years as an IC was actually in Red Team, looking at the entire Azure composition. And I felt that it was very hard for me to keep the mental map of the entire infrastructure as I'm navigating it. And I couldn't really answer the question of, is this worth the time? If I'm able to open this door, what's behind it, right? And did the Red Team identify sort of a needle in the haystack, or did we identify a systemic issue? So the ability to actually model what we're discovering and applying it back in a repeatable way was sort of the early beginning of that. I believe in 2015, I did a presentation at the Infiltrate security conference around data-driven offense, which I described a little bit where I was at the time in the very early beginning of what became, cartography and other things related to that. So it was really the ability to actually codify our thought process in a repeatable way, in an extremely large and ephemeral environment. So that was the initial sort of challenge in how I try to tackle it.
And so all of that at the Azure scale, right? So that's, you said around 2015, right? So I guess Azure was already super large at the time.
Yep.
So how did you decide to actually move forward and start building cartography? So, and maybe let's start with defining what is cartography for our listeners that might not be familiar with it.
Yes. So at the time it was within Azure. There was a few experimentation. I was looking at different challenge and decided to leave Microsoft after 11 years, and says, I want to apply the lessons learned. And I believe there's a lot of inertia and we can cut corner. So sort of the Amazon way of thinking, invent and simplify. I felt there was an opportunity in a smaller startup to go there. So I remember at the time, Mike Johnson was the CISO of Lyft, and I asked him, show me your dashboard. How are you driving, right? And we looked at the dashboard, and obviously we're early in the maturity phase. And what I committed to him is I will build you a dashboard. So we have actually a way of knowing, what do we have, how we make decisions, and so on. In addition, I was not familiar with AWS. And many years at Microsoft, at the time, Python was not the language common at Microsoft. So I came with a background in C++, Java, C#. So I was like, okay, as a new Lyft employee, let me learn the tech stack. And also let me represent what is this AWS cloud. I was very familiar with Azure. So that's how really Cartography was built is, hey, I've seen and I've experimented with sort of the decision loop, some benefits of mapping the world. Why don't we try this at Lyft? And I never want to write this again. So with Lyft, we work, not just myself, with a group of people. Now Lyft owns it. Alex Shantavi actually is the lead developer on it. So it really gave us, it was really an eye-opener of having the ability to actually correlate permissioning and being able to answer question, who has access to what, or what do I have access to, and then gradually mature into others' flows as well. So it became a very useful early investments as the company was going into, in my experience, an hypergrowth I have never seen before and probably will not see again.
Okay, super interesting. And so inventories were not like common back in the days. Mm-hmm. So I guess it's changing, right? Now most people have clouds. You have several vendors or tools that offer inventories. But back in the days, what triggered the urgency to build an inventory in-house? Was it like a breach? Was it things going out of control? Did you have like specific risks?
Well, the main thing is, what is the composition of the world I have to protect? So it really goes down to that essence is I'm accountable to protect what? We're talking about product. What is product? What is the composition of that? Infrastructure and so on. So that was the original need. Now, I would say additional motivators was hypergrowth in terms of our engineering. There's more and more people joining. I think I forgot exactly the number, but we were growing at a lack of a better term, insane pace. My philosophy was security organization is an empowerment function, not a dictating one, right? So how do I enable decision makers to make the right call? And for that, we need some data. Like I cannot bring in doomsday scenario all the time of high critical and just causing the panic. It just doesn't work. So that was the main motivator, I would say like stimulator there. The concept that we will not be able, it is very unlikely that we know everything that's going on, no matter how much effort we put in. So for example, you can add security questionnaires on new investment. You can do the scaffolding approach or paved roads approach in terms of all new services going, that's fine. But when you're in the tornado, those investment takes time. Now, how do you manage the risk as you're building up the foundation, right? So having the ability to represent the world, model certain expectation. Expectation might be only these services are internet exposed, for example, right? And being able to do the drift detection on that, where, hey, every time new services pop up, we get an alert. It's reactive, true, but at least the ability to know leads us to actually ask the right question and gradually debug things to build up the maturity. Lyft was also making some acquisitions. So overnight, suddenly something gets connected to the infrastructure that may expose the infrastructure even greater. So it was really the ability, sort of the catch-all mechanism, while we're building the maturity. So that was one of the main motivator, and why we implemented drift detection within cartography very early. It's just being able to codify, here's what we expect. We want to know everything, these things are no longer being met, so that we can pull the emergency lever and go investigate. Those were some of the reasons there.
Nice. So
in addition is enabling the security engineer also to observe and implement their very rapid iterations of questions. Oh, what about this? Like the sort of what if series of things that both security engineer and privacy engineers are asking. The ability to enable the rapid observation sort of analysis there became super powerful, because we ended up writing more and more sort of drift detections and data augmentation layer on top of cartography to even further enhance the visibility.
Nice. And so you said that you used cartography to take better decisions. I know Lyft was one of the thought leaders in terms of security as an empowerment and not as an naysayer, as you described. How would you say that engineers were using cartography? Did you build a tool for engineer, or was it still within the hand of mostly security people?
Yeah, so the security team owned cartography. The ability to observe was also shared to engineers. So the engineers themselves could actually access it. And what we ended up doing is also providing a view of the infrastructure and services to individual engineer. So we did some integration with developer portals within the company, where you could select a service. Let's say, what are the services that I own? Okay, A, B, C. And you can click on that service and you would actually see what it looked like in AWS. So Lyft was predominantly AWS, had some GCP as well. So the developers were also using that. What I've also noticed is engineering leaders were implementing drift detections on their own, because they wanted to model it says, hey, I want to know exactly when my infrastructure suddenly changed. Or because they had the context. So, hey, this doesn't make sense that so many people have access to it. Let me go shut it down on their own. So sharing that ability to kind of visualize the infrastructure also led to tremendous, I would say, increase in hygiene, service hygiene there, and conformance as well.
Okay, got it.
And the same thing applied, like the same concept. This is sort of an experiment at Lyft. Similar concepts were used within Amazon as well. Similar concepts are currently being used at Grammarly. So sort of the idea of mapping the world, enabling decisions, enabling visualization, both from human visualization in terms of UI, but also the ability to actually communicate in machine code, right? So you can start driving your workflows and automation, because all the assets and context is actually available. You can write very sort of agnostic scripts for recovery that are driven by that.
And so isn't it a bit today what you would expect from like an observability tool?
Yes, I think an observability tool can go even further. So the concept of initially cartography, or even there's some vendors out there right now, Jupyter One, which I spent some time at. Wiz is another one as well, which is like somewhat inspired or have very similar stack than cartography. It's representing state, so it basically captures the state, but doesn't ingest events, right? So we're discussing earlier about real time. There's some, CloudTrail is not necessarily real time. There's always a delay, right? So there's always the cloud propagation delay that plays in it. But you could also enhance this visualization or contextualization using logs and telemetry and additional events to get there. So I think observability would provide even additional context that are more event-based in different data source than what Cartography or Wiz or JupyterOne are doing right now.
I do believe that. How did you manage to integrate Cartography or whatever similar software you could be using today? How did you manage to integrate that within the engineering best practices? Because like you still need some action from them when, I don't know, they spawn a new AWS account, when, I don't know, they change something on Terraform. How did you ensure that flow was adopted by them?
Mm-hmm. Well, I mentioned earlier, you can drive a lot of automation using it, right? So if you actually share this context, the developer can use that particular context to actually enhance their product. I think one of the most effective way, I would say from an impact perspective at scale, was I don't know if this is a common term in the industry. I refer to it as green team. So green team is there to help. The original concept of green team was to actually make everybody green in their KPIs. So it came at Microsoft. So we're looking at key progress indicators in security. There were some questions about accuracy, right? Because a traditional two-dimensional database doesn't allow you to actually go sort of lateral movements and effective permissions, for example. They would look at just one permission, didn't actually compile it or build the effective permission. So when we provided the graph approach, then suddenly the KPIs became much more reliable and very descriptive and accurate, which may have led to some of the KPIs being more on the red side, right? So you can use the approach of, hey, go fix your things, but if you're looking at scale, I think it's very important for security organization to actually push and empower the engineering and actually legitimately do something about it. Don't bring just problems, bring solutions. So one is we enhance the accuracy of key progress indicator in a much more accurate way, and transparent way, which led us to know that we weren't finding needle in the haystack. It was systemic issues, right? And then we build up a team that is actually there to move people into the green state. And that's where it became interesting, where all the data allowed us to actually understand what was the pattern being used. And then we actually suggested code fixes, patching, and so on to engineering team. So we were guiding them. So for example, they would have a security dashboard where they see the engineering manager would see their issues, and on some of the issues, they would see a green button, right? And the green button was just click it, fix it. A good example of that is what I've seen in Sneak, and more tools have that, is a vulnerable libraries, here's a PR to just go fix it. We were implementing this at a much broader level within Azure, and I've seen this in more scale environment at Amazon, for example. So really kind of integrating it into the sort of issue discovery in a very accurate way, but also delivered even much more substantial impact in terms of fixing, right? So over permission. Hey, you have over permission, here's the users, here's their relationship, here's the nested group. Oh, there's a strike here, there's centrality here in terms of one of the group that overexpand the permissioning. just that visibility alone, the developers mean they're not malicious. They're like, this doesn't make sense. Thanks for the information. Boom, remove that. Suddenly your risk gets reduced. So that's how it was integrating into engineering, is enabling them to get that visibility, and then up to automating some of the fixes for them or in collaboration with them.
Okay, so I understand. Still, what you're describing is improving security, right? But as a developer, you're not usually primarily incentivized to do security, but rather to ship something that works, right? So, how did you build that motivation? For
I don't think the inventory. I don't think inventory is the motivation. It enables them, it empowers them to get that visibility. I fundamentally believe that engineering leaders, as well as engineers, are accountable for running a profitable, reliable, and secure service. So the accountability is the incentive. You are accountable of what you're producing. So I think that's more of a cultural engineering. I've had a great mentor. He says, Sacha, this is all great. At some point, you have to become the benevolent dictator. I get that. There's certain points where you got to go push forward. But generally, the motivation should be there early on in your hiring process, right? And they are empowered to make the trade-off decision. That's why I'm so cautious about what I refer to as the doomsday. Bring the empathy to the engineering side. They own the space. They don't mean to actually do. They want to be proud to produce, to release a quality product. There's some risk trade-off there. We are there to clarify, illuminate them into those decisions. Very rarely escalate, right? So going back to your question, is just the fact that they are informed helps them tremendously. The fact that you are, for example, I think an interesting investments I've seen is like one of the weakness of threat model is it's only accurate for today, right? So you do your threat model, the ability to actually go validate assumptions throughout from the design documents. We cannot, like cartography and inventory doesn't really play there, but we can influence and design. When the codes start getting implemented and pre-production gets populated or even production, then we can actually start notifying them about, hey, there's deviations between what the original design was intended to do versus how you're implementing, right? The whole space of data access, for example, which I think is where I want to mature the inventory, is have the understanding of like how data comes in, how does it get crunched, and how does it get out. That's an area where observability, I think, can really bar raise. So the ability to actually go validate the threat model and some of the assumptions, pre-production doesn't look like that, or suddenly you're starting using different libraries and so on, is guidance and scaffolding for the engineering team, but also a good telemetry visibility for us as well to see, hey, things are changing. And we do look at that as we have like continuous learning mechanism. I call it operational excellence meetings, where some of the assumptions are being reevaluated as, oh, there's a trend changing, what's happening, right? Or we're suddenly seeing network flow that we are not accustomed to. Let's go investigate, right? It doesn't mean it's problematic, but now we can go back to, hypothetically, if you use a graph, you can say, okay, this new VPC data flow, let's go label it, it's known. Okay, this is fine. Oh, these ones that just showed up are not. So that's how generally we've integrating it. But at the core is the scaffolding guidance to engineers to make the best decisions.
Okay, super interesting. Thanks, Sacha. That's really music to my ear when you said we ensure cultural compatibility since the hiring process, and I think it's a given today that developers, for instance, own quality, right? We don't have much QA teams that will evaluate the quality of something. Developers now, it's in their DNA, right? They want to ship something that works well. And I think we are transitioning to the same for security. And obviously, that movement is more recent than the one of quality, but definitely engineers should own security. So yeah, I think you described. Yeah, go ahead.
You are accountable for what you produce. Now, are you informed or educated? Right? Developers, we're asking a lot from developers. There's a lot of challenges. Let's not forget the sense of urgency in a highly competitive space. What is the risk tolerance? Let's go navigate those questions. There's a lot of ambiguity there. Let's get as much information as possible, but let's not look for perfection, else we're not going to be, security is going to become a bottleneck, right? So it's finding the right balance. I think with the inventory, the data, the contextualization, it helps us quite a bit. Also, it allows us to know that certain assumptions are no longer being met. But for me, it's imperative that really security is there as an empowerment function, and I want to legitimately describe how my team is improving the fixed velocity. Yelling doesn't work, right? What are we legitimately doing there to, one, eliminate the fact that we don't have these issues in the first place? We should always look at eradication permanently. The other thing is there's vulnerabilities discovered all the time. How fast are we discovering it? How fast are we fixing it? We've described earlier briefly security intelligence. I think meantime to discover a vulnerability might be between when the CVE is out and the CVE is out and when we actually discover it in our environment. Let's go measure that, reduce that. Perhaps security intelligence might aspire to negative time to discover, right? Is we've seen signs of something going on and we've made corrective measures and then we found out that it was a vulnerability. I think Log4j may have been seen as somewhat December-ish. There might have been some indicator much early in the year there. Some of it is inventory, some of it are just pure proactive mechanism and kind of dive deep into that space.
Fully agree, Sacha. So in terms of how it's done, so I guess using the cloud as a framework or as a foundation is what makes similar tools possible, right? Because you have a bunch of APIs that help you discover state, etc. Mm-hmm. And so could you describe maybe at a high level the architecture of an inventory? I guess crawlers, databases. What did you add some specific technical choices that you made, some trade-off?
That's a deeper topic. There's two, just top of mind, two things that I think really help push the bar and really kind of, I was facing headwinds from a technology perspective. Relational database are not good at multi-step correlation. And diversity of environment makes it very challenging as well, right? So I think two areas that I would say simplified things quite a bit is the concept of monoculture within cloud. You have a monoculture, you have a set of APIs that are descriptive and consistent, removes the diversity there. So it made things a lot simpler early on with Azure, AWS, same with GCP. I haven't looked at Oracle, but I'm assuming that is the same, or Alibaba Cloud, which I'm a little bit familiar with. So monoculture, sort of descriptive API, consistency of environment, really made things a lot simpler. The second is, I think, graph database was definitely a 2 o'clock in the morning discovery one night while I was working on it. I think probably 2013 or 2014, where I asked Google, "Hey, I need a graphical database, not visual, but graphical database." I was, working very late, and I had almost unlimited compute access at the time in my role at Microsoft, and I was just not getting. I was having a lot of issues implementing past the hash mapping inside Microsoft. Like, I wanted to implement, here's actually the visibility of all possible past the hash given a spearfishing user, multi-hop permissioning, right? And I was just spending a tremendous amount of money on SQL and compute, and I was still not getting clear answers. And the emergence of, I think it was an early beta version of Neo4j changed things completely for me, right? I could finally actually get the visualization. So I would say in the cloud is monoculture, consistency of API. The environment is very descriptive, predictable. You can get all the insights, both from metadata and discovery as well as action. Very simple. Technology advancement in terms of the ability to correlate, do multi-hop queries, adding much more contextualization very quickly in a cheap way, I would say helped tremendously. So we have Neo4j, which I've worked with several times. We got the Innovation Award when we worked with them at Amazon Payments. AWS Neptune, I almost forgot the name. AWS Neptune, I think, is another area. There's a bunch of other graphical databases that are now available, some open source, some commercial. My experience with Neo4j has been great since the beginning.
I love the story of the discovery when trying to map past the hash propagation.
It was a very large environment, and I think some of it was skill, some of it was technology. So kind of like the two of them together to do nested unlimited query hop and actually get the full visibility was extremely complex. And would have been, at the time, was very custom to pass the hash. I could not implement other ones. So for example, in the red team, we're developing new pivoting, which we actually shared with Andrew Johnson at Infiltrate. I believe it was a few years after the data. I think it might have been 2017, 2018. It would have been actually 2017, right before I left for Lyft, where we actually describe additional lateral movements in cloud post exploitation, which all our presentation was graph based. So we're obviously using the graph in the back to actually model these things and then go eradicate them.
Are you the author of the quote attackers think in graph and defender thinks in list?
No, I would quote that to John Lambert, but definitely who was within the similar circle at Microsoft. So that quote goes to him, but definitely lined up very well with my thought process. I'm also more visual thinker. For me, like, I don't care about list, right? What I do care is, like, what is the road to the asset I'm trying to go compromise? And the road is multi-hop. It's never one line. And we have proven time and time again that an asset that appears to have low value, when you actually look at what it's connected to, provided an interesting attack vector or a path towards objective that was completely overlooked. So hence the really having the ability to contextualize what is this asset in the whole scheme of things. And for example, I think a lot of people overlook right now assume role between AWS accounts. That is actually a lateral movement that is very effective and very often forgotten. I haven't seen a lot of tools, security scanner and cloud conformance tool, that really, some of them actually highlights the fact that the assumed role is there, right? But I haven't seen really one that actually tells you that over multiple assumed role, you end up with database access. Attackers are very interested in those paths.
fully aligned. And so
Yes.
you described so using like graph databases like Log4j, but you also mentioned earlier that you had some performance issues while you were working at certain scale. So what did you hit as a performance issue? How did you manage to solve that? And what was that scale to break the database?
Well, the early scale challenges were, I think, a mix of technology and skills on my end, like SQL Server, relational database, were just not, in my opinion, adapted for that. Large infrastructure means a lot of data. So I think that the scale issues are really kind of ingestion. It's not specific to inventory. It's more, how do you actually build a high performant, low cost, like cost effective ingestion pipeline. And also graph are, I wouldn't say immature, but horizontal scaling on graph is at really early phase. So you have Neo4j now that actually offer some of the horizontal scaling, or you have to go build it on your own. So representing state at such a large scale in a repeatable way, let's say hourly or daily, not unique. The scaling challenges are not unique to inventory. It's just overall kind of ingestion pipeline and sort of the like how do you actually organize your read and write permission, write partitions and things like that. But that's at the, I would say at the Uber scale. Vendors, I'd rather at this point where we're at is I'd rather go with a SaaS vendor that I know can scale and just sort of write a check and so you handle that, and I actually spend the money on talent, intellectual horsepower to actually go do something about it.
Yeah, of course.
I'm much more in a build, in a buy prioritization versus a build prioritization for undifferentiated aspect of security, right? So vulnerability scanning, inventory are not unique to Grammarly, and spend the money on resourcing on what I consider differentiated is the space of generative AI. And we spoke earlier about LLMs before the podcast. I'd still want to buy there, but unfortunately the options are not available. So we tend to gravitate more in terms of extend and build at that point.
Which I think is why you built Cartography initially as well, because like nothing else. And I think Netflix built also something similar. I'm not sure they open sourced anything, but I think they also built something like in the 2016 or something like that.
Yes. I think Netflix was more similar, more around data flow and network mesh, which, but Netflix I think is a good gold standard in terms of how a security team should operate and communicate transparently. So they've released a lot of things. A lot of it is extremely valuable.
Yes, I agree. So if you don't mind, I will quickly share the Cartography repository, so people will be able to understand what Cartography looks like. Can you see my screen?
Yes.
All right, then perfect. And I'm gonna zoom in a bit. So this is Cartography. So that's fully open source, right? And so yes, powered by Neo4j database. And so we can see like a screenshot of the tool. So the graph ability is obvious. You can see lots of resources represented here, supported platforms and everything. And so it's super well documented. We can see that there are community meetings. So I don't know how active the community actually is, but there is actually like a real process for developing things. And so we can find some more information in the documentation with things such as interesting tutorials, but also much more detail on the product itself, how you can actually programmatically query cartography and get some information with, for instance, filtering on EC2 instances that are exposed to internet and things you would expect from an inventory, acquiring some specific attributes on cloud assets. With so a lot of examples that are described here.
And just the flow for cartography, just to clear, and there's several presentations. I think the more descriptive one is the one at RSA, I believe, in 2018, or actually no, sorry, 2020 RSA presentation on it. The idea is let's actually it connects to multiple data sources. So AWS, you can have Okta, G Suite, Azure. It pulls all the data, builds a cohesive schema out of it. Then the next phase is data augmentation. So what are some of the analysis and correlation that can be done on the graph to augment the graph? So the label Internet Exposed, for example, is actually an analysis job that understands VPC permissioning and so on within AWS and Azure, and actually traverse the graph and add additional labeling. So there's a series of analysis job. And then the third, last component is the ability to actually get drift detection. So you can describe what you expect the graph to look for, and after the graph is actually updated, it compares previous and current state and alerts you and says, hey, something changed that you didn't anticipate. So that's generally kind of the three-phase: ingestion, augmentation, and then drift.
Yes, and so that's also reminds me a lot about Datadog. So we described about observability products. So of course, Datadog is primarily an observability product, but on top or along with the security product, we are obviously using the state that is pulled from your cloud infrastructure. So you can find cloud information. You can find applications. We also have specific inventories that are built for services, so that are not pulling information from the cloud, but from, for instance, the APM, with a way to add ownership information into it, which is a question for just after Sacha. And so what we can find in this resource catalog, obviously, are also we can map with the findings that a resource might have. So for instance, here we have a security group, and we can see that yes, we have SSH access, RDP access, etc. And that's the demo app, obviously. So the interesting thing with that is that, funnily enough, we build things that you can find in other inventories, so such as Cartography. And so one way to look at it is you can get the resource point of view on your findings, right? So on rules, as you described, Sacha, that might show deviations or failures compared to what your expected state is. Mm-hmm. And so, yes, we also have important business information, such as publicly accessible resources, and which you can use as a filter, and which is a natural enrichment that will really help you prioritize and look at the things that you have that are, for instance, in that case, publicly exposed.
Just to touch briefly on Internet Exposed, Internet exposed is not a binary. It's not a yes or no. Very often, right? What I've seen recently, I think it was the product Orca Security, which I thought was a nice touch, is sometimes you may have resources. I think full internet exposed, you should go take a look at it. There should be very few, right? So for example, within Grammarly, we know exactly which one they are, and we're paying attention in terms of increase there and decrease. Partner connectivity is another one, right? So what I like what Orca did is they actually really, and I talk about this, I think on one of the B side is, okay, true internet exposed, but also internet routable to where. And the mechanism for us is to, whenever these things happen, investigate where's the destination, right? So Orca, what they did is they actually map common routes like Cloudflare or Akamai or routes to certain vendors as well. So for example, I believe I saw, okay, this is actually allowed in by Tenable or Qualys, right? So adding that additional layer to save people time in terms of sort of the panic. Oh, there's a new internet host exposed, but is it like internet only, everyone on the internet, or is it particular partner? Giving that visibility automatically, I think, helps also with the prioritization, right? I've seen cases where for simplicity, and especially with people with multiple cloud, is they start opening clouds from clouds. So let's say AWS to GCP, and using the entirety of AWS IP range is not limited to your own VPC, right? Oh, let's just enable AWS. Well, you're actually enabling everyone in AWS. And by the way, a trial will enable you to be in that IP space, right? So having clarity in terms of, yes, it's internet routable to who, I think it's another layer of context that perhaps like Datadog, I've seen Orca, actually, I was pretty impressed when I saw that. It's minor detail, but helps the prioritization quite a bit.
Yes, fully aligned. And defining what is public accessibility for like a microservice that could be nesting down load balancers and maybe applicative routers, maybe a queue. What is public accessibility? If you cannot reach it directly from a TCP IP standpoint, but you might reach it from a HTTP, not even HTTP, but from a applicative standpoint, maybe the GraphQL query is flowing through SQSQ and is reaching unfiltered the service, then is that public accessibility? And I agree with you, there is a lot of nuance in this.
It's extremely complex. I think, in my opinion, the resource provider design approach within Azure allows people to ask questions to a given resource, who has access to you? Within the space of AWS, the IAM policy language is very powerful, but with that power comes a lot of mistakes. And asking from a context perspective, like who has access to what, really, like the conditional aspects are very important here. Depending on who or how you ask the question, you may get different result based on the condition, based on the context of the caller. Which goes back to my comment about, the importance not just of inventory of asset, but contextualization is a must.
Yes, fully aligned, Sacha. And contextualization, you have like technical contextualization. You also have information about ownership in terms of cloud, but also in terms of teams, and eventually business contextualization. What is the business sensitivity of this asset, which is not something that is obvious to discover in an inventory, which is like by definition built from a technical standpoint. And so that
the whole space of attribution to owner is a complex one as well. So we haven't talked about that today.
So that was my last question, and maybe we can finish with this one, Sacha. What process do you have around like finding owners for those resources?
The approach I've seen has been custom in every environment, right? So I think I've seen some vendors try to tackle it. Mapping. So I would say the most common way is cost center, right? You start digging into cost centers, you'll uncover what is perceived as who is actually paying for this, which may not be the right owner. So if you work in a small company, cost center tends to have a high reliability. In a very large company, like some of the companies I've worked for in the past, you're talking 200,000 employees to 1 million employees, with a lot of people moving in different direction. The cost center becomes less and less reliable, right? So you may attribute back to a cost center saying you own this. It's like, I built this like 6 years ago. I don't own this, right? So I think to answer your question, the graph helps a lot. So you can do heuristics and pattern analysis, and I call them pat solvers. Can you correlate the last merge with an instance? Yes. High likelihood that the manager organizational structure, you can have some visibility there, right? Do you have an inventory of who's owner and how accurate is it? No matter, I've seen inventory defined in Git. The company expands, suddenly, it's not valid. So I haven't seen really kind of a commercial solutions that really tackles this in an effective way. Everywhere has been custom. The fact that we have the ability to, I call it pat solvers. So if you ingest GitHub, you ingest AWS, you ingest Jenkins, you can start mapping things from repo down to assets in AWS, right? Now, if you start ingesting PagerDuty and you actually know who is on call for that particular service, suddenly you have a name. If you map the organizational structure through AD, through Okta or Workday, whatever, suddenly you have a position in the organizational structure that you can start pivoting and make decisions, right? So this is how, for example, at Grammarly, we are able to carve out a dedicated security dashboard for all engineering leaders. Is we actually map the asset and navigate the organizational structure and apply a filter. So each directors can actually go see the state of their own security because of that. Never seen a commercial tool that does it. It's been custom everywhere I've been.
Yes, I love it. Mapping it to the organization, organizational structure programmatically is indeed really interesting idea for a complex topic to solve. And what coverage would you say you have on ownership today, or what's, if you don't want to answer for Grammarly, what do you think is best in class in terms of coverage attribution?
The approach I've used at both Amazon and Grammarly is the concept of unhealthy issues. Unhealthy issues are orphan issues. By default, we are the owner as part of security. So there's like two categories of unhealthy. One is orphan issues, like we don't know who actually owns this. This is not a desired state, so we do measure that, and we drive it down to zero. Or the goal is to never have these things. The second is sort of issues out of SLA, which is irrelevant to attribution. So that's, to us, is unhealthy state. As part of our operational excellence, we do measure that and we drive it down as hard as we can. So that's the learning function. Attribution, some of it is clear 100%, some of it are weaker, right? I would say Grammarly is not at the place where we have overly complex, organizational structures and so on. It's not at the level of Amazon, where a lot of conversations were, hey, I actually don't own it, but you do own the cost center. And it was good awareness that I am actually paying for this out of my budget. I didn't know, right? So it was more around like moving the right cost centers. But we had very good internal organizational structure and asset management that we can pinpoint to the cost center. Now, the reality is they were no longer the right owner. They did the right thing, and suddenly the right owner showed up. So yeah. You're not making progress if you don't measure. So we do measure the case where we can't find the owner. Marketing, marketing campaigns do not report to engineering. So how is this asset correlated to repo? There's none. It's a third-party contractor. Those are the ones that I would say come more regularly, that at least we know and we go and tackle them right away.
Very interesting. I like measuring ownership as a success, or at least as a progress metrics. Thanks a lot, Sacha. That was insightful. Really appreciate our discussion on inventories. I think that gives a lot of pointers into implementing that and on the value behind such tools. Maybe next discussion around LLM's security, as I know you're hiring for.
Responsible AI and generative AI are the area where I'm spending most of my time on right now to make. Grammarly must be the best custodian of context and knowledge management. So it's imperative for us to do this. We're doing it pretty good. The bar, we have a tenet that we're never done there. Also, on final, we've talked a lot around the build prioritization. As you've alluded, some of the things I've built in the past were not available. I highly cautious people to build these things. I think the market has got a lot better. The inventories are a lot better. Correlation. Datadog is doing great work there. Wiz is doing excellent work. Jupyter One is doing great work there. Orca as well. So there's a lot of vendors now that really, Cartography is available. It is highly extensible, very cheap, but you still have to operate it, maintain it, and so on. But ask yourself, should I be building this or should I be buying? I would recommend focus on buying.
Same. Thanks for the wise words, Sacha. Thank you so much for your time on the Cloud Security Lounge. Izar was not with us today, but he will come back for our next episode. Thank you so much, Sacha.
Okay. Merci.
Merci.
Right.
Have a great day.
Thank you. Bye. Bye.